Hello again. So, exploring modulo congruence even further, let's examine the following problem. Of the 100 smallest natural numbers, how many are congruent to each of the following? 0 mod 7, 1 mod 7, 2 mod 7, 3 mod 7, 4 mod 7, 5 mod 7, 6 mod 7. Well, natural number just means numbers starting at 1 and going on and on and on up from there. No decimal values. So, we're starting at 0, really, but whatever. So, let's think about this. And let's set up a table because tables make things organized, and organization is key, especially when we're going to come across problems with these. We're going to have a lot of answers. All right. Now, in the previous problem, we observed how we can think of mod 4 in terms of the division algorithm, or in terms of multiples and stuff, and remainders. So, let's continue that idea, where if we were to list out, every value going from 0, 1, 2, 3, 4, 5, 6, then what we would want to do is repeat, because we're in modulo 7. It never becomes 7 itself. So 7, 8, 9, 10, 11, 12, 13. And we can just express all of this in terms of expressions, like 4n for the first column, 4n plus 1, 4n plus 2, 4n plus 3. Oh, what am I? Oh my gosh. I'm still stuck on the last problems thinking. 7n, 7n, 7n plus 1, 7n plus 2, 7n plus 3, 7n plus 4, 7n plus 5, and 7n plus 6. And I can even say that this is 7n plus 0. Now, we can start filling out this table fairly efficiently. So let's just keep extending, extend, extend. And there we go. And we just can list all the values from 0 to 100, the smallest 100 natural numbers. So we have 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56. And, you know, you could probably fast forward in the video to when I'm done, but just know if you ever think of these problems as too long or too tedious, hey, I'm doing them right along with you, so no complaining. 60, 61, 62, and we're just going to have to go out further. 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, almost there, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90. Woof, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. Oh my gosh. Alright, and we are good. I am just going to, let's go and extend all this out. So, a little bit of tedium. That's because I don't take any shortcuts. If we want to fully understand a problem, sometimes that tedium is helpful because we have to spend that much more time engaging with it. That's my justification anyway. Okay. So, of the 100 smallest natural numbers, how many are congruent to each of the following? Okay. So, let's basically, we're just counting like everything in this first column is the same as 0 mod 7. Everything this second is 1 mod 7. They're all congruent. So, we just have to match up the total number of values in each column with the n that we are using. So like in our first case, the smallest natural n is 0. And that's how we get all the values in this row. So like 7 times 0 plus 0 is 0, 7 times 0 plus 1 is 1, etc., etc. Then we have when n is equal to 1. That generates all these values. N is equal to 2, and so on. N is equal to 3. N is equal to 4. N is equal to 5. N is equal to 6. N is equal to 7. N is equal to 8. N is equal to 9. N is equal to 10. 11. 12. 13. And 14. Wonderful. Okay, so when it asks us how many of the smallest 100 natural numbers, how many are congruent to each, all we have to do now is basically just like count up the n values. because that's how many the number of rows in each of them, and the number of rows is going to, for the number of rows corresponding to each column is going to be that total number. So how many are congruent to 0 mod 7? Well, 14. Of the smallest 100. How many go with 1? Whoa. How many go with 1? 14 again. How about 2? Seems to be 14. Well, how about 3? Oop. Well, it cuts off at 13, and so do the rest. So the rest are just going to have 13 of the smallest 100. 13. And that is it. Took a little bit of tedium, but not too bad. And now we have this kind of way of thinking where everything in this, I mean, we're just developing the previous thinking. This is, everything in this column is just 0 mod 7. This is 1 mod 7. 2 mod 7. 3 mod 7. And so on and so on. So we've also we can see some very interesting results. For example, I can take any number in like this column, so 23 and 72, and now I know that 23 is congruent to 72 mod 7. Specifically, that they're congruent to 2 mod 7. I could take something in this row, so 34 and 90. Now I know that 34 is congruent to 90, which is congruent to 6 mod 7. Because it's in the 6th column. And this is just a very easy way to imagine all the congruences that are generated. And we'll learn more about these things called congruence classes and stuff in future videos, which are very much related to this procedure.